Good morning, thank you for watching this video. Today we are going to see an example on how to create throughout the preprocessor GIN an input file for GoZone. In particular, today we are going to start with a simple example of an office building called case study number 1, having a compartment geometry of 20 by 20 meter with only one opening in the compartment, defined with a sill height of 1 meter and a soffit height equal to 2.5 meters. The height of the fuel is considered to be 0.3 meters, uniformly distributed in the compartment, and the total elevation of the compartment, floor to ceiling, equal to 3 meters. Now let's open the graphical user interface GIN in order to start creating our problem. If you have some doubts on how to install GIN, please go back to the previous video and see how to set this preprocessor. The first thing to do arrive to this point is to create a new problem. We have to choose the location in which we want to create this new problem. So in particular will be case 1. We can call it case 1, okay, without the extension in, save. You see, case 1 does not have an extension geo. We need to have an extension geo because we need to communicate with GMSH, so assign it as a geo extension, and we can use whatever kernel we want. Let's go for Open Cascade. Now what we have to do is to define the geometry of the compartment. So starting with point, we go in geometry, elementary entities, point, and what we do is start to give coordinates at location 0, 0, 0, add, then the second one 20, 0, 0, add, 20, 20, 0, and then click on add, 0, 20, 0, and click on add, and also we have to give a point for the window, so 10, 0, 0, add. When we finish, we close and we press the key Q. As you can see, we have 1, 2, 3, 4, 5 points. What we do now is to go in geometry, elementary entities, add a line, and we have to specify the first point and the second point to add the line. This is the first line in blue. We do the same for the contour of our compartment. Voila. When we have done, we press the key Q. And then we define a plane surface. In order to define the plane surface, we have to select one line, press the key E, and then Q to finish. When we have done this selection, we now have to associate an elementary entity to an elementary entity a physical meaning. In particular, GoZone think that a point can be associated with a physical group representing a window. So let's assign to the point in coordinate 10, 0 a name, a tag name called opening 1. The tag can be whatever you want. We can start with 1, and then we press E to confirm, and you see that when you confirm, you have the color that turns from black to blue, and then we can close these windows and press Q. We have to do the same to associate an elementary entity such as a curve to a physical meaning or a physical group that is representing a wall. So we can give a name tag wall 1, tag number, I start from 11 to the wall, I select the first wall and press E, and you see blue, so it took correctly the assignation. Then wall number 2, you see the tag is automatically changing so I have to select only the second wall and press E to confirm. I do the same process, exactly the same process for the rest of the wall. E, and then when we finish we can close and press the key Q. We do the last step with the surface, to which we are going to assign a fuel name, and we have to click on our surface, press E, and then press Q. When we have done that, the other step is to define the mesh. So we go in Modules, Mesh, Define, Transfinite. We transfinite the curve according to our need. I want to have a mesh of 2 meters by 2 meters, so I give a number of points on this line as 11. I press E and then Q, and that's it. Then I want to transfinite the surface, left side. I click on the surface and I press E, and then I press Q. The same way I want to recombine this surface. Recombining the surface means turns the triangular element used by default in GMSH into quadrilateral elements. And then I select the surface and press E, and then I press Q to exit. When this is done, you can either define the mesh by clicking on 2D or press the shortcut 2 in your keyboard, and you see your mesh in your building. Now what we have to do is to define the problem in GoZone related to general settings. In particular, we want to have an input file, and this input file will be case 1, an MSH file, case 1. Why not? The input file is going to feed GoZone. The MSH file will be the file thanks to what we can see the post-processed results. The initial temperature in the compartment is 20 degrees, so 293 Kelvin. Time step of 1 second, okay. Time print of 30 seconds. Simulation time we put 180 seconds. The fire origin by default is in 00, but can be changed. Why not? But let's take 00. It's in this position. Then height of the ceiling, we say 3 meters. Number of ceiling materials 2. Why not? Number of floor materials 1. Horizontal opening, no, we don't have them. Neither forced ventilation and transfer file. At this point we save our data and then we refresh. We have now to define the ceiling. We have 2 materials. In particular, the material 1 is the one closest to the inner side of the compartment, to the internal side of the compartment, and so it will be 0.05 meter of gypsum board, and then the second one is 30 centimeter of concrete. The floor is made of 30 centimeter of concrete, so let's click and modify, and this is done. What we have to do now is to define surfaces, lines and points that as I told you before, they represent the fuel, the walls and the openings. Let's start with the fuel by clicking on cell definition. We click on the surface defined before. If you don't see the parameters appear, you have to refresh your problem and now repeat the same. Voila. We have to define the fuel in terms of rate of heat release density, that is for an office building is 250 kilowatt per meter square, fire glow rate 300 seconds, design fuel load 511 megajoule per meter square, and height of the fuel 0.3 meter. Confirm. You can close this window where you have the properties have been assigned to the surface. Now you have to do the same for the walls, selecting wall definition and then the first wall. You see appearing a box asking wall thickness and ceiling material. Okay, we have a first wall thickness of 0.3 meter made of bricks. If you don't have other materials, you don't change the parameter that you have by default here, the software will understand. Then you confirm and you have your selection taken, and you do the same for the other walls. We assume the walls to be all equal, and do the same process I've done for the first wall. Confirm and then close. Wall definition, line, confirm, selection, and then close. As the last step, we do it for the opening, clicking on the point representing the opening, physical point 1 opening. We say that this windows was of width equal to 5 meters, and then seal 1 meter and soft width 2.5 meter. First point coordinate is the first point coordinated is the first boundary representing a windows as a line. So we have 7.5 because it's 10 minus 2.5, and y is 0, and then the second point is 12.5 meter. Breaking Windows laws, stepwise variation, it's okay. Confirm. The properties have been assigned to the opening. Now the last step is to create the GoZone input file. When you see that down writing case 1.msh, it means that the operation went well. Where we can find this file? We can retrieve these files in the folder in which we have the original executable of gene, not in the shortcut location. So folder gene, and you see here the input file created with this interface. That's it for today. Thank you for watching. See you the next time.